Hello, third year. This video could well be actually the last video for straight line. Um, we need to just have a quick look at the general form of the equation of a straight line. Okay, now it's a different way to present the same information that you've been working with for the last several weeks. Okay, so although it looks slightly different, I absolutely promise you, you have all the skills necessary to deal with it. Okay, it communicates the same information in a slightly different way. What this will do is it will draw on your skills of rearranging a formula, okay, which is similar to solving an equation, and there'll be a little bit of fraction work in there, okay? But apart from that, it's really not any different. So the general equation, or sorry, the general form of the equation of a straight line is given as ax plus by plus c. All right, now a, b, and c are all numbers. They could be positive or negative. They could be fractions. They could be whole numbers. They could also be zero. Okay, so they could be um, any of these things. All right. If I was to put it into some sort of numerical example, just to try and sort of help you get your head around it, this would be an example: 4x plus y minus 3 equals 0. That is still the equation of a straight line. Okay, it doesn't look like what you've been used to dealing with, because what you've been used to dealing with is something y equals mx plus c. It doesn't look like that, but we can make it look like that, all right, which is what we really want to do. So what we want to do here is rearrange into the y equals mx plus c format. So we need to rearrange things so it looks like a y equals mx plus c equation. Because once we have it in that format, we can do anything we like. We can do gradients, y-intercepts, we can do graphs, sketches. We've done all that. So we just need to do a bit of rearranging. So obviously, look, if you look at this equation carefully, I want to keep the y on the left-hand side, so that's going to stay where it is. The two things that are going to do the moving, I want mx and I want plus c on the right-hand side, so the 4x and the negative 3 are going to do a bit of moving. Okay, so I'm going to have to move those. Whoops. Let's just get rid of that highlighting. Tidy that up. Oops. Right. So the y is going to stay where it is. I'm going to want to deal with this 4x first of all. All right, now that's a positive 4x. I hope you can see that. So what I want to do really is I'm going to subtract 4x from both sides of this equation. So I'll get y minus 3 equals negative 4x. And then I want to deal with this minus 3 now over here. So I'm going to do plus 3 there, and I'm going to add 3 on both sides there. So that's y equals negative 4x plus 3. I have added quite a bit of work in there to that rearrangement. If you don't need these, please just don't do them. All right, you're under no obligation to write those down. If you can just complete those 3 steps, then please go ahead and do that. As long as you get it right, I'm happy with that. I'm just going to take those away. I hope we can now see that that is actually in the form. Look, y equals mx plus c. Yeah, so we should hopefully see that m now is equal to negative 4, and the y-intercept, which we know is c, the coordinates for that would be 0, 3. Okay. Now that final interpretation is stuff you've been doing lots of. Okay, that's not new. You've done loads of that. So the only bit that's new to this really is this rearranging step here. Okay, that's the new bit. Let's have a look at one more example. Now this example is a little bit more complicated. Exactly the same process, the numbers just behave slightly less well, but that's the reality. So we've got 3x plus 6y plus 9. That looks quite nice. I mean, as nice as a straight line equation can look. You know, there's no negative numbers in there, there's nice whole numbers, they're all multiples of 3. It looks like quite a nice equation. When we rearrange that to become y equals mx plus c, it's going to start looking a bit less nice. Hopefully that will let you see why sometimes the general form is actually a nicer way to present the equation. So let's rearrange this here just now. I want to keep the y's on the left hand side, and I want to move the x terms and the numbers across to the other side. So I'm going to have 6y is equal to negative 3x, because I'm going to have to subtract that, and that's going to become subtract 9 as well. So negative 3x subtract 9. I've done that rearrangement in one quick step there because it is stuff we've done before. I hope we can understand that. If you can't, please get in touch with me. Now, in order to deal with this 6y, I'm going to have to divide by 6 because that in effect says 6 multiplied by y. So in order to get down to just a single y, I've got to divide by 6. So that'll be negative 3x over 6, and that will be minus 9 over 6 as well. So a couple of divisions by 6. Now we should be able to home in on that and notice that we can simplify these fractions. So that'll be negative 1/2 x minus 3 over 2. And that's us finished. Okay, that is we're now in y equals mx plus c form, aren't we? I'm just going to rub that out actually. So that's us in y equals mx plus c format. If we were asked the gradient, we would be able to state that that's negative 1/2. And if we were asked for the y-intercept, we would be able to state that that's 0 and negative 3 over 2. Okay, again, that last bit that I've done, you've done lots and lots of times before. That's just interpreting the straight line equation. The new bit is this rearranging, okay, and this bit here. These are the new steps. So it's rearranging the formula, really. That's all there is to it. Look at the difference, so you can see here, that's y equals mx plus c, and that's the general form. That down there looks a lot less nice than that up there, and that's why sometimes we present it in that format. Okay, so the steps. Rearrange into the y equals mx plus c, and then you're doing exactly as you have been doing. You can find your gradient, your y-intercept, you could even draw a sketch. Okay, all these things are available to you. If you need any help at all with this, or you're not sure about anything, watch the video, stop the video, have a go at it. You don't have to watch the video in one sitting, you can go at it as many times as you like. If you want to see this solution as it is on the screen now, you can go into your class notebook, content library, into straight line, and then this one's called the general form of the equation of a straight line. It's quite a mouthful. If you're unsure of anything, if I've done anything in the video and you're not sure why I've done it, then get in touch with me by Teams or Glow email is fine. And if you tell me the time of the video when you stop understanding what I've done, I'll be able to look back and kind of home in and help you from there. That's really not a problem. So have a go at these questions. That is probably going to be the last exercise we do on straight line for a while, but it could come up. There are 5 questions. There's quite a lot involved in this sheet. Okay, I will give you a decent deadline on that. I'm not going to rush you through it because you've also got your negative numbers work to get through as well. What I would say and what I would request is make sure you've done your negative numbers work first. That's really, really important, okay, because it is causing problems. And it might be worth waiting until you've had your feedback on your straight line problem solving assignment before you try and tackle this one. All right, good luck, and please get in touch if you need any help.